Welcome back to The Run, everyone. Today, we are tackling the Cambridge AS and A-Level Mathematics 9709 syllabus, and we are doing it with pure, unadulterated strategy. We're stepping into the explainer today, not just to review some math, but to launch a Cambridge exam strategy speed run. That's right, we are going to lock in on maximizing your marks against the clock. We are treating this exam exactly like a competitive esport arena, an arena that can be meticulously mapped, entirely optimized, and completely conquered before that active run timer hits 0. Right now, on our master interface, we're targeting syllabus section 5.1, representation of data. We are talking about the mean, the median, the mode, the range, the interquartile range, and the standard deviation. But listen to me. This is absolutely not about sitting back and reviewing basic, sleepy textbook definitions. No way. This is an elite insider strategy guide on exactly how the Cambridge examiners build their mark schemes, and more importantly, how you can exploit those exact structures for maximum point efficiency. Your mark velocity tracker, that beautiful metric measuring your marks per minute, needs to be fully maximized. You literally do not have time to second-guess yourself in that exam hall. You need precise, calculated execution. So, boot up, calibrate those calculators, get your screen layouts ready, and let's decode the examiner's playbook.
Right off the bat, look at that massive number 15 on the board. Now, this isn't a time limit, it is a raw score metric, and it is absolutely crucial you understand its weight. Representation of data accounts for approximately 15% of your total exam marks in this paper. 15%. That is a massive, game-changing return on investment. If you can optimize your pathing through these data representation questions, if you can learn to process standard deviation and interquartile range calculations at a rapid, flawless pace, you are essentially guaranteeing yourself a massive score buffer for the rest of the run. But, and this is a huge but, because it's worth so much, the examiners have aggressively layered this section with specific command word traps and brutal time sinks. We're talking about the kind of traps that will absolutely wreck your pacing. If you approach this casually, if you don't map your route, you will bleed minutes and you will bleed marks. Your mark velocity will tank. We are here today to analyze those time saves versus time sinks and ensure that performance drop does not happen to you.
So here's our battle plan for the explainer today. We have 5 specific checkpoints we need to clear to secure those top band scores. First, core principles. Second, mastering terminology. Third, the method mark strategy. Fourth, the tactical framework. And finally, checkpoint 5, top examiner traps. Let's initiate the run.
Checkpoint 1, core principles. We need to dissect the precise route metrics the exam is actually measuring. Let's pull up the map layout.
Before you write a single number on that page, you have to understand the optimal route. What is the Cambridge examiner actually asking you to do? Because they aren't just checking if you know how to push buttons on a calculator. According to the Cambridge examiner reports, the assessment objectives for section 5.1 target 3 entirely distinct cognitive domains to secure top-tier marks. First, knowledge and understanding. This is your baseline, your foundational code. Do you know the exact formula for standard deviation? Do you know, without a second's hesitation, that the interquartile range is the upper quartile minus the lower quartile? Next is application. This is where you deploy that raw knowledge efficiently onto grouped frequency tables or cumulative frequency graphs under time pressure. But here is the secret sauce: analysis. Analysis is your absolute highest scoring tier. This is when the examiner asks you to compare the mean and standard deviation of 2 totally different datasets and explain, using words, why one set is more consistent than the other. If you misinterpret a Cambridge command word here, it slows down your text output and causes an immediate massive drop in your grade potential. The conceptual framework of this exam is built entirely on systematic analysis and evidence-based reasoning. Rote memorization will only get you through the early levels. Analysis wins the whole game.
Let's transition to checkpoint 2, mastering terminology. The exam requires you to know exactly when to deploy a measure of central tendency versus a measure of spread to optimize your path.
This visual brilliantly illustrates the ultimate divide in the exam hall. Let me bring you into our co-op challenge arena to explain this. Imagine we have 2 candidates. Let's call them Player 1, Alex, and Player 2, Sam. On the left side, we have pure mental clutter, knowing the math. This is Alex's playstyle. Alex might be an absolute genius at calculating the raw standard deviation. But when the timer starts, Alex gets totally bogged down detailing secondary evidence points. Alex wants to slow down to outline basic textbook definitions, drawing out unorganized tables, and completely ignoring strict examiner conventions. This causes massive time loss. Now look at the right side, presenting the math. This is Sam's playstyle. Sam is a fast writer who moves at incredibly high speed, throwing high-velocity analytical thesis links onto the page to maximize score acceleration. But wait, Sam writes so fast that they skip command word parameters. Sam doesn't use proper headings, uses incorrect formats, and fails to clearly annotate their cumulative frequency curve. Both of these players, Alex and Sam, are triggering massive marking penalties. If you are Alex, you time out. If you are Sam, you lose accuracy points. The true optimal route requires strict adherence to examiner conventions, proper headings, correct terminology, appropriate formats, and crystal clear annotation. You have to perfectly merge Sam's speed with Alex's accuracy.
Moving right along to checkpoint 3, the method mark strategy. Let's look at how to actively secure points even when your execution goes a little off track.
I am going to read this crucial alert directly from the principal examiner reports with you because it is literally a cheat code. Quote, "Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you." End quote. Guys, this is your ultimate safety net in the exam. It's your extra life. The examiners actually want to give you points. If they look at your page and see you correctly identifying the midpoints of your classes, systematically multiplying them by the frequencies, and setting up the standard deviation formula flawlessly, they will award you method marks, the M marks. They'll give you those marks even if your calculator output at the very end is completely botched due to a sweaty-palmed typo. You have to shift your mindset. You are not just hunting for the right answer, you are methodically proving the correct process. You must understand the incredibly high stakes of proving your methodology on paper. Okay, time split check. The active run timer is paused. Before we execute this final top band paragraph and lock in an A-star grade velocity for this explainer, you need to optimize your subscription feed. Subscribe to Ace the Exams at Ace the Exams right now and turn on all notifications. Seriously, visualize that little gaming notification bell ringing. No matter if you are running IGCSE, O-levels, AS, or A-levels, this channel is your absolute tracking center to outpace the clock and beat the examiners. All right, unpausing the timer. Look at the screen. Show you're working. I am emphatically drilling in this core warning because it is the most vital takeaway. When you process data, clear working is completely non-negotiable. It is the absolute armor that protects your grade buffer. Never, ever leave the examiner guessing how you arrived at a number. Document your exact route.
Let's hit checkpoint 4, the tactical framework. To maintain high mark velocity, we need a standardized procedural sequence to execute these complex data questions without freezing up. When you flip that page and your screen buffer loads a massive, intimidating block of raw data, exam anxiety is incredibly real, but we are going to transform that panic into systematic, robotic execution. Here is your highly tactical 5-step problem-solving sequence to absolutely eliminate hesitation. Step 1. Deconstruct the question. Scan the command words. Are you estimating the median from a curve or calculating it exactly from a list? Step 2. Extract relevant data. If it's a frequency table, do you need to add a cumulative frequency column? Just do it instantly. Don't even think. Step 3. Select the analytical framework. Are we using the coding method to save massive amounts of time on huge numbers? Step 4. Execute with clear notation. This is our M-mark strategy in action. Show you're working. Document every single step. And finally, Step 5. Present with correct terminology. Don't just generically say, the spread is bigger. You need to say the interquartile range is greater, indicating greater variability in the middle 50%. That is how you clear the mark scheme checkpoints. Now let's look at how to maintain your run splits when you encounter a structural roadblock mid-paragraph. Sometimes you'll be writing out your analysis, and your evidence drops out of alignment, slowing down your mark tracking. This is where you deploy the deconstruct solve evaluate loop as an optimization template. Think of it like the classic Peel paragraph structure: point, evidence, explanation, link, but customized for high-level math. Let's say a question asks you to compare two athletes and make a recommendation. First, identify the given info. Athlete A has a lower mean time but a higher standard deviation. Second, break into logical steps and solve systematically. Third, check reasonableness. Do these times make sense for human runners? Finally, make justified recommendations. By smoothly transitioning into your counterarguments, for example, pointing out that while athlete A is faster on average, athlete B is more consistent, you rewrite the text out loud into a pristine, high-scoring block. This loop is exactly how you unlock those highest-order descriptive, analytical, and evaluative marks.
And here we are at checkpoint 5, top examiner traps. The examiners have specifically coded trapdoors into the exam to catch players who aren't paying attention. Let's expose them right now.
I am handing the controls over to you for a live, interactive, viewer time trial workshop. Let's simulate this. Challenge 1, the 60-second trend extraction. Imagine a highly complex Cambridge source graph flashing on screen with a 60-second countdown timer. You have to extract the trend. Most people fail because of mistake number 1, using the wrong approach for the context. They calculate the mean when the data is heavily skewed by extreme outliers, instead of optimally routing to the median. Don't fall for it. Challenge 2. Spot the performance leak. Imagine a flawed student paragraph on screen. Where is the exact line costing them 4 critical marks? Usually, it's mistake number 2, forgetting to check format and presentation. It's drawing a histogram, but forgetting to label the frequency density on the y-axis, or leaving out the key on a stem and leaf diagram. Instant point drain. And finally, mistake number 3, answers not specific to the context given. If the data is about sunflower plant heights and you just blindly write dataset A is more dispersed than dataset B, the digital highlighter turns red. You lose the mark. You must say the heights of the sunflower plants in set A are more variable. Context is everything.
To truly master that contextual awareness and breeze past those traps, you must understand how to thoroughly evaluate evidence. This is where you prove you aren't just following a script. True critical analysis in representation of data requires identifying alternative interpretations and strict limitations. For instance, are there assumptions being made in a grouped frequency table? Yes, absolutely. We are forced to assume that all values in a class fall exactly on the midpoint. That is a massive limitation, and you need to address how it affects your final conclusions about the standard deviation. If you can clearly outline the boundaries of your statistical evidence, you are no longer just a high school student taking a math test. You are demonstrating university-level analytical maturity, and the examiners will gladly reward you with the maximum possible marks for your run.
All right, we are at the victory screen. We fully mapped the route. To distill this entire session, you need to internalize our 3 universal optimization rules. Rule 1, the 60-second command word scan. Always know what cognitive domain you are operating in. Rule 2, the marks per minute budget allocation. Deploy the marks strategy to secure partial credit and protect your grade buffer. Rule 3, the final 5-minute quality review pass. Always check your real-world context before moving on. I leave you with this final provocative question to challenge your entire exam mindset moving forward. Are you just doing the math, or are you executing the examiner's playbook? It is time for our final call to action. I need you to subscribe to Ace the Exams at Ace the Exams, click that notification bell so you don't miss our weekly speedrun tutorials, and drop a comment down below right now sharing which specific Cambridge unit framework you find the hardest to clear under time pressure. Let your comments dictate the route for our next masterclass. Get back to those past papers, keep your mark velocity high, and keep optimizing.